In this video, we'll be using the circular function h of t is equal to 2.5 minus 2.5 cosine of 0.5t to model the tide in Malibu measured in feet above low tide, where t is the number of hours since the last low tide. The first thing we're asked to do is to graph h of t in the window from x minimum equals 0 to x maximum equals 25, and from y minimum equals 0 to y maximum equals 6. To do that, we're going to utilize the Desmos graphing calculator. Our first step is to go to Graph Settings, make sure that we're in radian mode, and then adjust our x-axis settings to 0 to 25. I'm going to use a step of 4 to match our grid. And for our y-axis, we're going from 0 to 6. We're going to enter our function as h of, instead of t, we're going to use x, equals 2.5 minus 2.5 cosine of 0.5x. And we can see that that produces a sinusoidal curve with 2 complete cycles. In part B, we're asked to sketch the graph on the grid. In order to do that, it would be helpful to have a table of values. So we'll use Desmos to create that table. Go ahead and click on the cog for Edit List, and it gives you an option to create a table. We'll start with 0, and then 4, 8, 12, 16, 20, and 25. And not only does it create the table, it also plots the points on the graph. So we can start with the point 0, 0. Next we have 4, 3.5, 8, 4.1, 12, 0.1, 16, 2.9, 20, 4.6, and 25, 0. Now it's still not very clear from these points how to sketch the graph of the curve. So one of the things that we might do is to try and find our maximum and minimum points. If we click on the maximum, we can see that it occurs at 2 pi 5, which is about 6.285. 6.285. Our minimum occurs at 4 pi 0. So a little bit to the right of 12 we have 0. Our maximum is at 6 pi 5, and it looks like 6 pi is at about 19. And now we're ready to draw a rough sketch. For part C, we're asked to label on our graph the points that correspond to high tide and low tide. So high tide will correspond with our highest points, and our lowest points will correspond with low tide. Part D asks us, how high is high tide, and at what time does it occur? We already looked at that earlier. High tide occurs at 2 pi 5 and 6 pi 5. 2 pi is a little bit more than 6, and 6 pi was just a little bit less than 19. So looking at our units of measurement, the height is measured in feet and time is the number of hours since the last low tide. So the answer to the first part would be 5 feet at 2 pi and 6 pi hours after low tide. In part E, we're asked at what times during the 25-hour period is the tide 4 feet above low tide? Mark those points on your graph. So one way to answer the question is to look at our graph and look at 4 feet above low tide. It appears that we have 4 different times. Those values are approximately 4, 8, 18, and 22. Now to get better estimates, we can go back to the Desmos graphing calculator, and we can type in y is equal to 4, and then we find the intersection points. The first one's at approximately 4, the second one at 8, the next one at 17, and the last one at about 21. So our first one, let's say 4.4, so we can refine this. T is approximately 4.4. The second one, 8.1. The third one, 17.0. And the last one, 20.7. So my graph was fairly accurate at the beginning, but then not so accurate towards the end. Now if we go back up to our function, what we just did is we wanted to find out when h of t was equal to 4. And so what we did is we solved the equation 4 is equal to 2.5 minus 2.5 cosine of 0.5 t. We had already graphed the right-hand side of the equation, so then we graphed the left-hand side of the equation. We found out where the two graphs intersected each other, and we came up with our values of time in hours. In part F, it says that Kathy walks along the beach only when the tide is below 1 foot. Find the intervals on your graph when the tide is below 1 foot. We can approach this one similarly. This time, instead of drawing a horizontal line at 4, we'll draw one at 1. And we mark the intersection points on our graph. And we want to find out when the tide is below 1 foot. Well, that would be starting at 0 and going to our first intersection point, starting at approximately 10 and going to our next intersection point, and then starting at our last intersection point until 25. So we're trying to determine when is the height less than 1. H of t is 2.5 minus 2.5 cosine of 0.5 t. We want that to be less than 1. We don't have the tools to solve that algebraically yet, but from the graph we can see that that occurs when time is greater than 0, actually I guess greater than or equal to 0, and less than our first intersection point. To get that, it looks like it's at about 2, but on our graphing calculator we can change our y equals 4 to y is equal to 1. Find our intersection points. The first one's at about 1.9, but if we round up to 1.9, then the tide will actually be more than 1 foot. So I'm going to go ahead and round down to ensure that the tide's not too high. So 1.8. Between the second two, we have 10.7 to 14.4. And then for the last one, t must be greater than 23.3. Now if we write that in interval notation, it would be the interval from 0 to 1.8 union the interval from 10.7 to 14.4 union the interval from 23.3 to 25.